Hello students, today I discuss about simple harmonic motion so with uniform circular motion. So I represent the equations how can we establish the equation of simple harmonic motion for any particle. So here we assume first that t is the time period and omega is the angular velocity of the directed point p. So omega is the directed point of the with the angular velocity omega, which rotates anti-clockwise direction from the point x. So here we know the relation by the definition of time period that t is equal to 2 pi by omega. So this comes from the definition of time period, and also from the definition of frequency we can write down frequency is equal to 1 by t, which is equal to omega by 2 pi. So we can write down omega, the angular velocity, is equal to 2 pi n or eta. So here frequency and angular velocity are related, so I denote it by equation 2, and this equation the time period and the angular velocity omega is represented by equation 1. Now here we just to establish the simple harmonic motion equation, we first find out the displacement of the of point p. So here p is the directed point rotates anti-clockwise with the angular velocity omega. I have taken in this figure. Here center of the circle is O, and x I have taken the diameter here of the circle, and I have drawn Pn is a perpendicular on the diameter x. So here the angle PON taken theta, we have taken theta, the angle PON, and the radius of the circle is taken A. I have taken the radius of the circle. So now the projected point N, if we have taken a perpendicular from the point P to the diameter x, then N is considered as the projected point of the directed point P. So N is the projected point of the directed point P. So here N is the projected point of the directed point P, which continues simple harmonic motion. So here in place of P, which rotates anti-clockwise through the circle, with this point the projected point N actually shows the simple harmonic motion with this with the diameter. So point P rotates with the circle, and N just goes through from x to x less and x less to x. So N actually continues the simple harmonic motion. So how we can establish this? Here I have taken at any moment t the displacement of N from O is On. We have taken this is x. So displacement of N from O is taken x. This is x actually. This direction is x. So x, and OP is the radius A. So here if we take the triangle OPN, then this will be right triangle. This is OPN, this is perpendicular. So ON by OP is equal to cos theta. So here we have ON by OP is equal to cos theta by the right triangle OPN. So ON is equal to OP cos theta. If we put the values, x is equal to A cos theta. So now x can obtain maximum value at a point where cos theta is equal to 1. So x can take maximum when cos theta is equal to 1. So cos theta takes value 1 if theta is equal to 0 degree. So since the point starts from the point x, so it takes the maximum distance a, the radius of the circle a, if the theta becomes 0 degree. So it will take the maximum displacement. So here A is actually called amplitude. A is the amplitude of x, the displacement of the particle. Also, the angular velocity omega I have taken of the directed point P is equal to theta by t. We know this relation. So here theta is equal to omega t. So by the equation 3, we can write down x is equal to a cos omega t. This is a first you can say equation of the particle x. So this is the required equation of simple Harmonic motion, which represents particles amplitude, angular momentum, angular velocity, and with the particles displacement. So this simple Harmonic motion equation of the particle simple Harmonic motion of the particle represents the relation between amplitude, angular velocity, and displacement of the particle. So if we put the values of 1 and 2, I have obtained already here 1 and 2, then this equation can be written down in this way. X is equal to a cos 2 pi t. 2 pi t is the time period, and this is small t, the time taken to displace of the particle from the position O. So also it can be written down a cos 2 pi eta t. Eta is the frequency and t is the time. So it is written down as equation 4, and this equation can be written down in sine form also. If the particle rotates clockwise, not anti-clockwise, if it rotates clockwise, then clockwise motion of the P, the particles simple Harmonic motion of the particle can be written down sine omega t or a sine 2 pi eta t. So if you like this video, then like, share with your friends. If you have any comment, then comment me.